Hi, today we're talking about T confidence intervals. These are confidence intervals that are calculated still for the mean, but when the sample standard deviation is given instead of the population standard deviation. So a couple of things about the t-distribution before we get started with calculating those confidence intervals. This is the first time we've looked at the t-chart, so you will need to find that in your formula sheet packet. The t-distribution is still bell-shaped and it's symmetric around the mean. The mean, median, mode are still at the center of the distribution. The curve never touches the x-axis. But here are some differences between the t-distribution and the z-distribution. The variance of the t-distribution is greater than 1. The t-distribution is a family of curves, and that's based on the degrees of freedom, which is connected to the sample size used in the prompt. And as n increases, it approaches the normal distribution. So the bigger the n value, the bigger the degree of freedom value, and the closer the curve comes to the normal z distribution chart. Degrees of freedom are calculated by taking the sample size and subtracting 1. So here's a visual of the t-distribution family of curves. Notice that this first small dotted line has less area in the middle and more area in the tail region. Now this curve is telling us that this has a degree of freedom of 3. The medium dotted line, notice it puts more area in the middle of the curve and less in the tail region. And the degree of freedom, and therefore the sample size, went up. The degree of freedom for this one is 10. As that sample size continues to increase and the degree of freedom continues to increase, it puts more area in the middle and less in the tails. And so for an n value of infinity, it would be the exact normal distribution, which is this solid line in the picture. So again, the larger the degree of freedom, the closer the curve comes to the normal distribution. All right, so the first thing we're going to have to do is find critical values. So we found critical values on the z-chart for when the population standard deviation was given. But since we're not going to be given the population standard deviation, we're going to be given the sample standard deviation. That is when we're going to use the t-chart. Okay, so this first one we're going to go ahead and look at together. We're finding the critical value for a sample of 20 and 90% confidence. So notice in this left-hand column, degree of freedom is labeled here. So I would first need to find the degree of freedom that's associated with a sample size of 20. Basically, guys, you're just going to take that sample size and subtract 1 from it. So 20 minus 1, that gives me 19 degree of freedom. So I'm going to be looking on the 19 degree of freedom line. So I locate 19 degrees of freedom. Across the bottom, you will see various confidence levels. I want to go to the 90% confidence level, and then I just see where these meet. So I'm going to go straight up and straight over, and I see the value 1.729. That is going to be the T critical value that we would use when we're calculating a confidence interval. All right, guys, pause this video. Find the critical T value for a sample size of 10 with 95% confidence. All right, hopefully you paused the video and you found, first of all, that a sample size of 10 would have 9 degrees of freedom. We locate 95% confidence on the bottom of the chart, and we see where they meet, which they meet at 2.262. So the T critical value is 2.262. We would use that if we were finding a confidence interval, a T confidence interval. Okay, so speaking of those confidence intervals, let's take a look at the formula. The formula looks very similar to the Z confidence interval formula, except for we're finding a T critical value. So we look on the T chart to find that T critical value. And instead of being given a population standard deviation, we're given a sample standard deviation. So that's S instead of sigma. Taking a look at the first example, it says 10 randomly selected people were asked how long they slept at night. The mean time was 7.1 hours and the standard deviation was 0.78 hours. Find the 95% confidence interval of the mean time. Assume the variable is normally distributed. All right, let's go ahead and identify our numbers. The first number was 7.1, and that is talking about the mean. So I'm going to label that X bar. The next one, this standard deviation, is talking about that sample mean. So that is a sample standard deviation S. They're asking us for a 95% confidence interval, so we're going to have to find that value from the T-chart. And then also 10 was the sample size. It's kind of hidden because it's written out in words. So take a minute, guys, and let's find first degree of freedom. We want sample size of 10, so that would give me 9 degrees of freedom. And we want 95%. Pause the video and find that critical value. Okay, that critical value was 2.262. So if we plug those values into the formula, X bar 7.1 plus or minus the T critical value of 2.262 times the sample standard deviation of 0.78 divided by the square root of the sample size, which is 10. We know that we could plug and chug this in our calculator using the formula, but guys, just like the Z confidence interval, there is a calculator function for the T confidence interval. So I'm just going to show that. So we go to stat, over to tests, and the Z interval was number 7. The T interval is number 8. Again, we have stats because we have the mean and the standard deviation. The mean for this example was 7.1. The standard deviation was 0.78. The sample size was 10, and we wanted 0.95 or a 95% confidence interval. We're going to calculate. All right, so my confidence interval is from 6.542 to 7.658. We would still write the interpretation of that confidence interval. So I am 95% confident that the true mean time spent sleeping at night is between 6.542 and 7.658 hours. All right, that was the first example. Let's go ahead and take a look at the next one. This one says the data represent a sample of the number of home fires started by candles in the past several years. Find the 99% confidence interval for the mean number of home fires started by candles each year. All right, notice guys, we just have numbers written out here. So in the prompt, it doesn't tell me what the mean is. So I don't know X bar. And it doesn't tell me what the standard deviation is. And so if I'm calculating that, I would have to calculate a sample standard deviation. And again, I don't know what that value is yet. So going to the calculator, I'm going to go ahead and enter these values. I just went to stat and edit, and I'm going to enter these values into list 1. Okay, after we have those values entered, we're going to go to stat and calculate 1 var stats. My list is list 1, and I want the frequency list blank. I'm going to calculate that, and I get a mean of 7,041.4 and a sample standard deviation of 1,610 points. I'm going to round that to 3. We're going to go ahead and find the 99% confidence interval of the true mean. Pause this video and find that t critical value for a degree of freedom of 6 for 99% confidence. I have 7 data points there, guys, so I did 7 minus 1 to give me 6 degrees of freedom. Okay, pause the video and find that critical value. Okay, I found that critical value to be 3.707 from the t-chart. I'm going to plug those values into the formula. So 7,041.4 plus or minus 3.707 times the standard deviation divided by the square root of the sample size, which is 7. I'm going to go to the calculator to actually get the values. I'm not going to plug and chug that. I'm just going to go to stat, over to tests, and again, number 8 is the t interval. I'm going to highlight data. We entered the numbers in list 1, and we want a 99% confidence interval. So we get 4,785 to 9,297.9. The interpretation would say, I am 99% confident that the true mean number of home fires started by candles each year is between 4,785 and 9,297.9. All right, with that second example complete, I'm going to ask you guys to try this one. Pause the video here, calculate the 90% confidence interval of the true mean rainfall using a t-distribution, and come back to find the answer in a minute. All right, hopefully you paused the video and now you're back. I picked out the important information from the prompt. So N is 15, the sample mean is 2.7, the sample standard deviation is 0.78, and we want 90% confidence. So degrees of freedom would be 14, and the t critical value coming from the t-chart is 1.761. Plugging those values into the formula, we have 2.7 plus or minus 1.761 times 0.78 over root 15. I went ahead and used the graphing calculator to calculate the t interval, and I'm getting 2.345 to 3.055. So the interpretation, I am 90% confident that the true mean rainfall is between 2.345 and 3.055 inches. All right, guys, this concludes notes for today. So post any questions that you have in the discussion board.